seconds. And
okay, hello and welcome to the physics panel of, we're going to be speaking about the physics of wireless and radio, and we'd like to take questions from the audience. Does anyone have a question to start? Or?
This is how we explained that we didn't prepare anything.
No, we didn't prepare.
Well, it was always largely going to be a Q&A format.
Yeah. Perhaps we should introduce ourselves so people know who we are.
Yeah.
Start on the left. Well, my left here, your right.
Stage left, yes.
left.
Hi, I'm Joe Bender, otherwise known as Stormgren. Some of you may know me as. Been doing ham radio, wireless networking, and whatnot for quite some time. Got my license around 1993 or so. Was running IP on that in 1994 at 1200 baud on 146 megahertz, connecting to the internet, ham radio AmperNet. So I've been doing this for a while.
Hi, my name is Mark Lenigan. I have a degree in physics from the University of Michigan, and some grad school here and there, but I'm in the middle of that. And I've worked in community wireless projects. I got my ham license in the technician class last year about this time. And just generally been a physics and astronomy geek most of my life.
Hi, I'm Bunsen, or Brian, or KC2PIT. I'm a grad student studying physics. I've got my bachelor's at Michigan State and now at University of Buffalo. General physics geek. I got into ham radio a couple of years ago because it gives me an excuse to play with soldering irons and antennas. And
I'm Dennis, also known as P. Justice, KB8ZQZ. I've been licensed for about 13 years, and I'm making these guys do all the physics. Speak up?
yes.
All right. Should I redo all of that? Everybody more or less get it?
Hi, I'm Jeff, also known as Amish One, also known as KC8PUN. No, that is not a vanity call. That was actually the random one assigned to me. I've been playing with amateur radio for about 5, maybe closer to 8 years now. Day job, I build strange and fast networks for a living. For fun, I build very slow networks on amateur radio. So I believe the goal of this was to go around and take questions for the most part, because across this particular group of people, I have a strong likelihood that somebody will at least know where to go find the answer of just about anything involving wireless radios or networking, or both. So I will be wandering around if you guys have questions so that we can actually get them on tape so that the people who might listen to this later actually hear your question. So with that, anybody want to start off? It's 11 a.m. on a Saturday, and we have people in the room, yet nobody has a question.
Wake up. Yeah.
Where would you suggest someone look to get started in wireless networking, not necessarily looking for a ham radio license, but might have a rural cabin in Canada that he wants to get networking to?
So your question is essentially how would someone
get started figuring out how to do it?
Oh, get started figuring out how to do it. So basically, there's a rural cabin in Canada.
Yeah.
Is there
7 miles to the nearest road.
7 miles to the nearest road? But where's the nearest internet? Would be the question.
You could probably get a DSL line or something at the mainland. So that's 7 miles upriver.
Okay, 7 miles upriver, and you can see that location, or there's microwave line of sight.
If you had a big tower, you could.
Okay.
Well, for something like that, you would essentially pull bandwidth to the nearest point you could pull bandwidth to that you can. I mean, the trick with any of these, anytime you're doing any kind of wide area wireless networking, the key phrase is line of sight. Generally both sides need to see each other and kind of back up and actually bring this topically around. Most microwave signals, 2.4 gig included, which is all your 802.11b, G, and even your 900 megahertz for your canopy wireless stuff. They're all line of sight, meaning if they can't see each other and you can't point them point to point, you might as well not try. If there's a hill in the way, you're screwed.
if there's a lot of foliage in the way?
That's the other thing. Up at those frequencies, water starts becoming incredibly resonant. And as a result, you'll get where you'll be firing, 5 watts or whatever at something that's 10 miles away. And let's say you've got to go punch through a bunch of trees that you can, because it's like, oh, it's trees, it's insubstantial. The water in the leaves will cut that signal, will attenuate that signal down so badly that you won't even be able to tell that there was something on the other side if there's enough in the way. So you need to have clear line of sight. If you can't see it with a pair of binoculars from the top of the tower, that's your first problem. Also, getting started with something like that, don't buy crappy gear. Life's too short.
Yeah, Stormgren covered a lot of the topics. I would say if you're doing this point to point, like antenna-wise, the grid or mesh 24 dBi dish antennas would probably be the way to go because they're good and waterproof and weatherproof.
Yeah.
And basically, what you'll be doing is you'll set up one antenna and point it about where you think it is at the location, and then the other one you're going to sit there with a signal meter. NetStumbler works well for this, or if you can get I'm not sure if Kismet does that. I haven't really played around with Kismet.
It does.
Much. Oh, it does. Okay.
It does.
So NetStumbler or Kismet, you can get a gain reading from that, and you just kind of adjust the. Actually, what you're going to want to do is have a person at each end and slowly adjust one antenna and then the other until you get the maximum signal that you can get, and then clamp them down.
Yeah, especially if we're talking several miles of distance here, you don't want to have to keep driving back and forth to make little minute. Oh, okay.
When I say 7 miles up the river, I mean you get in a boat and you go up 7 miles.
Well, at least you're not hiking.
Okay, so you don't want to have to keep paddling back and forth.
That sounds almost like an application for satellite.
I don't like that much latency.
Yeah, see.
Also, satellite is very expensive.
What's the latency on a 7-mile boat trip?
What? The bandwidth of a station wagon full of magazines.
Or a canoe full of DVDRs, apparently. And actually, that does bring up a good point, and just so I can fit it in. You cannot break the laws of physics. Sorry, I had to do it. And that's actually the big problem with satellite that so many people have an issue with, is that you've got to go 22,000 miles out to the Clark Belt and 22,000 miles back. That 500 plus millisecond ping time you're seeing isn't due to bandwidth choking. That's
due to the speed of light.
Yeah, you're dealing with the speed of light at that point. It's significant.
Continues to suck to this day.
Well,
That's gravity.
so have we answered your question, or do you have a follow-on? Or
Well, would you recommend 2.4 gigahertz just for ease of getting the equipment and price, or is it worth going up to 900 megahertz? What equipment for unlicensed person is available?
Oh, well, there's lots of equipment available for that. On some of the installs that I did, now granted, it basically depends on your budget. And
Fairly small.
yeah, I kind of
But
figured.
It probably could be more than 802.11, but not
There's,
industrial.
a little farther. There's a set of wireless cards, or at least one model of wireless card, that's a 900 megahertz transmitter, but it speaks 802.11 protocols. And if you can go to 900, you win an awful lot over the water loss and the path loss in general, because it's much lower in frequency, obviously. So you might look into something like that. The antennas will be different probably, but you double the frequency, you have the distance typically, and at 2.4, which is where it is because of the water absorption line, you really get hit. So out there where you have a lot of trees and so forth, you do better at 900 with if you have to look through a little bit of green stuff.
Yeah, one thing I also will point out on those is the cards are maybe twice as expensive as a good Prism card. And a lot of times they're just Prism chipsets with 900 megahertz radios, to be honest. One thing I will point out is it's also very cheap to get 860, 900 megahertz beam antennas in the surplus market on eBay. You go on eBay and you'll usually find a whole bunch of those. If you do end up on 2.4, what is it? It's the bow tie feed, correct? Does anybody know?
Oh, you're talking
to the
about
satellite dish.
Actually, you can make your own feed. Are you talking about for beam antennas or for dish antennas?
For the dish antennas, I was going to, on 2.4, if you can get a pair of like, Bellevue, I guess up there is what the satellite broadcaster is, the old Primestar dishes. There's a feed that looks like a little bow tie that goes where the LNB, the little widget at the front of the dish, that you can feed a surplus satellite dish from and use that as a point-to-point link. I want to say, like I said, it's called it's a.
Well, basically, I know the antenna feed that he's talking about. An electrical engineer named Trevor Marshall designed it, and if you go to trevormarshall.com, he's got all of the plans to build this out of copper wire. It's a very simple project if you know how to solder. And if you don't know how to solder, I'm sure there's someone here who could help you out.
I've been watching a lot of municipal wireless projects implode after consuming a lot of money. Are people planning them poorly? Are they smoking crack to think it'll work at all? What do you guys think of this whole approach?
Well, first I want to know what you mean exactly by municipal wireless project. Are you talking about something that's being run by the municipality?
Yeah, you've got a whole bunch of cities that have recently failed in a big way around where I live, a series of cities that have started implementing citywide Wi-Fi. They've been implementing 802.11b, 11g in some cases. They throw up a whole bunch of equipment. They run with crappy service for a year or so. Then they say, oops, we were wrong, sorry, and then they knock down all the poles and give up.
Well, I'd like to start off with this question, because this is actually an area that I've worked in from many different angles. Like, as many of you probably know, I spoke on community wireless networking, which is grassroots doing this sort of thing. And, well, like most community projects, those are all run on a shoelace. But the municipal ones, I have had some experience in that, at least in Michigan. And what I saw happening was a lot of these, well, I basically saw probably dozens of these projects never really get off the ground. The city would scrape together the money for a design study. We would design the network, spec it out, tell them whatever they needed to do it right. And then they were hoping for a grant from the state or some foundation or whatever, or that they were going to get the funding to buy the hardware and deploy it. But because of the state of the economy currently, it never even got to the point where we're putting access points on pole tops or roofs or whatever. Now, the other thing is that, in my opinion, a lot of the problem in the mini Wi-Fi area is the problem of just basically local politics. That there's a certain way that a lot of cities run where, and this is, I think, essentially what NASA might call an endemic human factors problem. It's just the way people are. That you tend to trust people you know, but regardless of whether or not they may or may not be the best person to advise you on this issue. And so a lot of their network designs are suboptimal. For example, Wireless Oakland.
Well, and for a lot of reasons, I'll kind of run with it from there. There's a bunch of, other than political one, there's a lot of human factor stuff. Wireless Oakland's going to be the one I'm going to use as an example. It's as a project up in Oakland County, Michigan. They did a pilot project using the Cisco AeroNet Mesh product, which is a fine product for campus deployment. They were doing this over the entire county. And what these things do is they've got a 2.4 gig and a 5.8 gig stage, and you can set them up to backhaul on the 5.8 and provide customer access on the 2.4, so 802.11g versus 802.11a. There's a bunch of things that they don't take into account, or didn't take into account, and this is the problem with a lot of 802.11 based Muni projects. One is people aren't going to pay for it. The free service is too slow. They can get faster performance if they go by a cable modem or a DSL line. The areas they were deploying it in were already saturated for cable and DSL, sometimes with even multiple cable providers, and certainly multiple DSL providers. On top of that, it's implemented on an absolutely horrible technology. I'm not actually a really big fan of 802.11, especially in 2.4 gigahertz. You've got 11 channels theoretically, only 3 of which don't overlap with any other channels necessarily, or are clear or free of obstructions, 1, 6, and 11. And it's all unlicensed. As long as you emit in what's called Part 15, the FCC regulations, as long as you don't emit above a certain amount of power or a certain amount of gain, you can transmit in the band. So you have microwave ovens, which are sitting up, depending on the microwave and how old it is and how badly it's tuned, somewhere between channel 7 and channel 8. I've seen them as high as channel 10. That one was fun. It was also leaking like crazy. So the band, the signal-to-noise ratio, is terrible. Now, take these, and they're putting these APs, in the case of Wireless Oakland, every quarter to half a mile in very dense areas that if you were to war drive anyway, you're going to see in a given neighborhood 20 or 30 access points. So when it works, and if the funding is there and the political will is there, and people are actually buying it, the performance is still going to be terrible. You can't get around the fact that everybody can use this spectrum. This is why wireless or wired point-to-point services are so critical, and this is why recently you saw these huge 700 megahertz spectrum auctions. Everybody was wanting to get in on it, and the numbers were going into the billions of dollars. Because these people want licensed spectrum allocated purely to them so they can provide end-to-end service to their customers, all these cell carriers, and they don't have to worry about competing with 2.4 gig. The licenses themselves are hilariously expensive, so people say, oh, let's use unlicensed spectrum, and hilarity ensues.
Well, I would have to say on some of the municipal projects that I worked on, not the community projects, they were actually looking at using the 4.8 gigahertz spectrum, which is reserved for municipal and police agencies, and then also so that would be their primary communication and their backhaul, and then at essentially the last mile. The idea of a lot of these networks was we're trying to get Homeland Security funds so that we can upgrade our police communications infrastructure so they can do stuff like get immediate mugshots of already convicted persons into a laptop in their car or whatever. And then, oh, we've got all this bandwidth, and let's be honest, the police are not using the bandwidth. They're not maxing it out all day, all the time. So we're going to provide the surplus to our citizens as a municipal network. This is the model that I've seen a lot. Unfortunately, I haven't yet seen it implemented in the real world because nobody seems to get enough funding to get off the ground. So that gets around the let's use unlicensed spectrum because there's now new bands that are available for essentially this purpose.
And essentially that is true. And it works great for your backhaul, but if you're trying to provide this to your end users, being citizens of your community, ultimately, unless you're going to try to make them buy a radio, they've got to end up on the unlicensed spectrum at some point.
The other physical issue that, Oakland Wireless runs into this, and in a big way, is all of your, well, I won't say all, but the vast majority of your building materials, certain types of glass for a notable exception, are what physicists call a dielectric. They're insulators to microwaves and radio signals. So like, for example, in Oakland County, most of the houses are built out of clay brick, probably mostly in the 1950s. So Oakland Wireless is saying, well, you could pop open your laptop in your living room and fire up your wireless card inside of it and connect to our network on the pole top outside, and you're going to get signal. And people are complaining, oh, I'm only getting 54K a second as my speed. And I'm like, well, yeah, because the signal, actual signal getting through is so attenuated by going through the wall of your house that you are only connecting at the very, very minimum, basically, bandwidth that the protocol supports. You're probably connecting to, to an 802.11g access point at maybe 1 megabit a second and getting a throughput far lower than that.
Well, because it only sees a very small slice of the signal. By the way, passivated, that wonderful low-E argon shielded coated glass, great absorber of RF. Other one is aluminum siding. Some people who know me, I love to tell the story of I was sitting at home working one day as they were re-siding my house, going from aluminum to vinyl, and all of a sudden I could see 30 or 40 access points around me as the siding is being torn off my house. So yes, aluminum siding as well on a frame house, and a lot of houses in older communities where they are talking about deploying a lot of these as equalizers for broadband access. The houses are suboptimal as well because they're either that brick or they're
wood frame with aluminum siding. Yeah, that's pretty much Oakland County right there.
Exactly.
Oh yeah, steel lath.
Yeah,
Hi, Tiger and Froggy.
Yeah, steel lath house. If you live in an older house and you're wondering why you have problems, it turns out that steel lath, you got to have a certain amount of width in order to pass a radio signal through it of a given frequency.
Basically,
literally wavelength literally means how tall the signal is, and if that lath is short enough, it ain't getting through.
Like for example, 2.4 gigahertz, you're looking at a space about if the space is 60 millimeters wide, 2.4 inches or so, that's about the size of the wavelength. And the reason why we can't see it is because the wavelength's too big to fit into our eyeballs.
Yeah, actually. So if we were anime characters.
Yeah, if we were anime characters, we would all be able to see the microwave spectrum. Maybe. That would depend on whether or not we have cones, but that's biology, and I'm not really qualified to speak on that.
Anyway. Anybody else?
From a physical perspective, getting back to the interference and leaking you were talking about with overlapping signals from multiple sources and whatnot, is it physically possible for technology to improve at distinguishing signal A from signal B, even if they are using the same frequencies and possibly interfering? Or
Well,
is there like waves reinforcing and canceling each other that is actually distorting the signal?
Well-
or is it just making it more difficult for the receiver to distinguish them?
The answer to all of those things is yes, and
Yes, and I think Bunsen and I will get into this. Basically, what you're asking about, when you're talking about waves reinforcing and canceling one another, that is exactly the definition of interference, and it's a physical phenomenon. I know it occurs to all electromagnetic radiation. Like in the breakout sessions, I'm hoping we can maybe pull up the laser pointer and we can start showing you optical interference. But being that it's the physical phenomenon, you're kind of like the speed of light, kind of like, like Dennis said, the law of gravity. These are things you just aren't going to get around. There's a reason why we don't have anti-grav cars. Now, I maybe don't want to go so far as to say that because, people, I'm sure 150 years ago, someone would say, well, there's a reason why we aren't flying.
I was going to say, they haven't proved the standard model yet. Don't.
Well, the Large Hadron Collider is going online, I think, next summer.
Aren't they doing tests starting today, and tomorrow could be the end of the world as we know it?
Oh no. Okay, well, we're going to get into this.
Yeah, and anyway, no. Not to wander too far off. Yeah, so you can get physical interference. The other thing is that in a given radio, and what's going on with the wireless networking stuff, is the way you used to do it, and it's still done largely in a lot of things, is you take input signal in, you mix it with some other frequency with an oscillator, convert that down to a lower frequency, and then use components that could deal with that lower frequency. The problem with this is that that antenna is also receiving all sorts of other crap. So you can end up in this mixer stages as trying to down convert it to a lower frequency. So we can work with it. You can end up getting a ton of interference from other signals that are very close to it or are generating other. I'm trying to think of how this works, or trying to figure out how to explain this. You get combinations of frequencies and harmonics as stuff mixes that then interferes with it in the radio. Now, to get around that, and why I was saying the answer to your question, all of your questions is yes, is especially on the wireless networking stuff and the cell stuff, rather than down mixing it to the point where we can deal with this thing at a lower frequency than the 1.9 or 2.4 or 800 megahertz that we were dealing with, we're just going to pull the signal in at 800 megahertz or 2.4 gigahertz, and we're going to convert it and demodulate it directly without having to mix it, not having to do anything else. This allows you to use a lot more bandwidth, and this is because you can only stuff X amount of bandwidth into that lower frequency. If I'm dealing with a higher frequency, I don't have to make any trade-offs or sub-optimizations. And I can also start doing crazy crap in software. A lot of these could directly convert into these high-speed signals directly to the baseband, the actual digital media, and then just slam that into a computer and say, go do really nasty theoretical math on it that we can't actually do in physical hardware, but we can do computationally. This is how the MIMO multiple input, multiple output stuff works. This is how your average cell phone at this point works, really. Your cell phone is smarter than is a lot smarter than they were 10 years ago, and really are probably some of the most advanced communications devices we currently make, and they play MP3s. Go figure. But not to wander too far off, if there's enough delineation, like if I've got a signal, let's say on wireless channel 6 and have something on channel 7, I can probably discern a decent chunk of the signal on 6 in software, and if I'm doing these direct conversion techniques. However, if I got two signals sitting on top of each other, they're going to interfere with each other physically.
And once you're in that mix, the two signals are already mixed before they hit the antenna.
Before they even hit the antenna.
There's really, at least from a physical standpoint, I can't think of a way that you can really disentangle them when the antenna is receiving both. Now, this is part of the reason.
If they're just off enough in phase, you can do it in software, but you need a lot more processing power than most of these radio chipsets will do.
Well, the other cheap way to do it is diversity of antennas, which is why like Linksys WRT54Gs and all those little residential routers, wireless routers, have two antennae, because what they're hoping for is whatever the interfering signals are, they're only interfering at one point. So if you move a little bit, if you take one step to the left or the right, you will have you'll see a different pattern from the two signals, and then you can start again do some math in software or hardware, and that will allow you to disentangle the two signals. But from a single antenna, what you see is what you get. Is there anything you'd like to add?
Just to kind of summarize, there's only so much you can do on the receiving end. You are limited there by the physics, the fact that all the receiving radio can do is listen to the radio signal and try to pull information out of that. If you want to get better sharing of the bandwidth, you have to do that on the transmit end. You have to convince those transmitters to play nice with each other. But in order to share the frequency space, you also have to split the bandwidth up. And there's a limit to how much data you can fit into a given amount of radio bandwidth. So I'm kind of stuck there in the end.
Yeah.
Now, as far as modulation techniques, how different is what you guys are talking about from what would be used in like the higher speeds on your 802.11 routers, like QPSK, or how many bits per symbol?
Well, that's pretty much what's happening now.
Okay.
With the QPSK, the QAM, and like the OFDM modulations for 802.11g. Because what you basically are doing, and this is why it starts to work, and this is why I think this is why wireless draft N is taking forever to hit these speeds, because they are now hitting the physical limitations of what we can start to do in the hardware.
I thought there was also some legal problems.
Well, there are a bunch of legal problems, but initially there were also there are technical issues. They don't necessarily. Everybody thinks there's a slightly different way to do it. The problem is they're all right. Nobody's come up with, and there's a whole bunch of patents out there. It's a completely different issue, but. What you can get, and this is why B or G is preferred to B. B is very 802.11b is possibly one of the most spectrally inefficient things you'll ever run across in common usage. G works a bit better because they do significantly change those modulation techniques. They do significantly change where they put signal physically. I mean, you have the center frequency, and then you've got, if you imagine the center frequency, you basically have the whole signal widening out. In interspace between the center frequency and the edges of how much that channel space is are all of these little QPSK or QAM subcarriers. As opposed to the straight frequency hopping of patterns of 802.11. And so you can actually start adding and subtracting subcarriers, which is why you'll see a connection go from 54 to 36. It's I believe, hopefully I'm not wrong, and I don't get schmooballed in a minute here, it starts dropping, it basically starts, as it stops being able to listen to the fringes of the frequency, it starts literally dropping all these little subcarriers. So what modulation technique you choose, I guess to kind of come back around, and hopefully this is answering your question, does determine how efficiently these things can sort signal out and how efficiently they can process and send data. There's a little something called the Nyquist theorem. Mm-hmm. Nyquist says, if you only have like 54 megahertz of bandwidth, you're only going to be able to shove data into their up to 54 megahertz wide on a baseband level within physical limitations. How you encode that data or how you encode those symbols determines how much more efficient you can get, how much data you can send in a given second. QPSK is actually a really good example of that. between QPSK and OFDM, it's pretty much where everybody's going to. DVB-T and DVB-S, especially DVB-S, is all QPSK with some really funky, heavy math encodings on it to stuff as much into space as possible.
Okay, thank you.
You're welcome.
I just figured I would ask, what do you guys think about WiMAX? Will that ever be like a... is that ever going to do anything?
So I'm just trying to clarify what...
as a technology?
Okay, so your question is WiMAX ever going to be viable as a technology? Well, correct me if I'm wrong, but WiMAX is closely related to the 802.16 spec.
More or less.
More or less? Okay.
More or less.
I've always thought that both 802.16 and WiMAX are kind of more the triumph of marketing, really, over engineering, because I'm not saying they're bad technologies, but what I would say is I don't see where they're anything new, because largely what 802.16 is essentially giving people is the ability to put a point-to-point wireless link between two places, or at least when I was looking into the spec, this is what a lot of companies were coming up with, is, well, we can build these radios that connect to a network, a wired network on each end, and then you build a wireless bridge that can span some distance. And this is actually where, in the wireless industry, at least the part of it I saw, this is where all the money is, because T1s are, in general, for small businesses, are expensive. So if they have if they have 2 or 3 locations, a couple wireless bridges are fixed costs, whereas the T1 is a recurring cost every month. So that rather than spending the money for 3 T1s to all 3 of their locations, they can put in 1 T1 and 2 wireless bridges, or maybe 3 for redundancy, and ultimately save money over the next 5 years. And the thing is that prior to 802.16 and WiMAX, all of this technology already existed. There were already Proxim Tsunami bridges and things like that that can do this sort of thing. So it's kind of like, this is new technology, but it's ultimately accomplishing something that we've already been doing for years.
T1s are getting cheaper.
Yeah, I was going to say, T1s are getting cheaper with the UVerse deployments and whatnot. Business DSL is getting cheaper with the VRAD only 10,000 feet, or not 10,000, 2,000 feet away from you. It's easy to get a fairly fast DSL line that'll work for business, and you can VPN stuff together. WiMAX is going to be carrier driven, I think, at this point. Sprint is slowly rolling out XOM, for example. They're the only one I've paid attention to, because after a while I stopped caring about WiMAX. I'll be perfectly honest. You know, for 3 years I've been reading, oh, somebody's going to start rolling out WiMAX next month. Cricket, you know, nothing's happening.
Every year it's like somebody brings up, oh, WiMAX.
Well, WiMAX is supposed to run it's supposed to run on a combination of licensed and unlicensed spectrum. And I think until the carriers get on the ball, it's either going to be the next generation, because the other thing that's happening, because WiMAX is, you know, as they were working on it, things like EVDO and UMTS started showing up on the cellular market, and that's actually a lot more flexible, and people are willing to spend gobs of money on that, especially considering that even though you do have some mobility with WiMAX, from there you can do mobile end nodes, it's still not as flexible as the cellular stuff is.
And typically, EVDO is kind of cheap these days.
And EVDO is stupidly cheap these days. Where Sprint's using XOM, where I'm seeing them is replacing the old Sprint broadband MMDS point-to-point service, which they're rolling out. After the results of these latest sets of Spectrum auctions, I'd say wait and see. I wouldn't be surprised if somebody tries to do a WiMAX push and try to run mobile VoIP over it. But
are you saying WiMAX or take the WiMAX protocols and run them in 700 megahertz? Is that what you're saying?
I'm not sure. Everybody's been talking about, oh, the Spectrum auction is going to get WiMAX rolling again. I have no idea. You know, it sounds exactly like the same announcements I've been reading for the last 3 years in all of the trade rags and on the websites and all the press releases. So your guess is probably as good as mine personally.
I'd just like to put one last comment on this question before we take the next one. I think a lot of this too, again, this isn't the physics of wireless radio, but a lot of this is related to the economy right now. That there are people out there who want to do these projects, but whether they're a business or a municipality or whatever, they don't have the budget to do the rollout. So, you know, if the economy generally starts improving, I think you're going to see an explosion of activity in this sector. and some of these technologies that have been, well, like as an analogy in PC hardware, I remember reading about DVD and Bluetooth and USB and all these things back in 1994 or so, and it took another decade before I really saw the PCs I could buy in the store with those technologies. You know, and I kept waiting to upgrade my computer because I'm like, oh, next year this stuff's going to be out.
I've been reading some of the, not recently, but last year I've been reading some of the two-way radio trade publications about a technology that's dubbed as XMAX. I don't know if you've read about it. It's some proprietary modulation scheme, but it's they didn't go into a lot of detail about it, but it's apparently really making some noise in the industry as being able to use first of all, the business model is to use the unlicensed frequencies, the 902 to 928 band, and they've done some field studies apparently where a fairly low power repeater can blanket an entire city, and it's with a large number of users. Have you read anything about XMAX? Can you cover it if you heard anything about it?
It's probably along the lines of some of the more recent stuff, and I'm seeing Amish one kind of. He's thinking so, and he deals a lot more with the two-way stuff than
well, I mean,
do
it could be for data as well. I mean, it's not just.
Yeah, I'm familiar with the APCO stuff and the.
Yeah, it's nothing like that. I'll have to.
There's a lot of digital stuff, and just by the way, when you read these performance numbers, especially with any wireless system, two-way radio system of any kind, or wireless point-to-point, you're looking at it's no different than hard drive specs or computer specs. They lie. Oh dear God, do they lie? And yes, in theory, on a clear day with dry air, and I've got a 400-foot thing, 400-foot tower that I'm putting this gigantic gain antenna on top of, and I run a watt into that. Yeah, it's probably going to work and cover a very wide area. So you have to, when you see statistics like that, you have to look at how are they implementing that? Did they actually do a study and prove it? And if so, what did they do to do that? Because I've seen a lot of these that have come out to be pure and total snake oil, just like so many other things, because it was either theoretically never proven, or they did an outlandish setup that nobody would ever implement or could reasonably implement to cover such a wide area. Oh, by the way, this is also what they did with Muni Wi-Fi. A lot of Muni Wi-Fi statistics didn't take into account the fact that people have access points at home.
I should point out that some of them also didn't take into the fact that the Muni Wi-Fi was also going to set up more than one access point. So the numbers are absolutely wonderful as long as you have exactly one access point. The moment you try and deploy two, even if they're cooperating with each other, the numbers drastically reduce.
Yeah, especially you look at your average trunking system with the new APCO P25 digital radios, which is all your cops now are going to digital radios, and they're very easily encrypted, and they're not easy to listen to. There are scanners now that can hear them, but it's more spectrally efficient, and they can digitally switch all the packets now. So. But yeah, I mean, statistics like that, it's like one access point at 400 feet and two users, two radios on the system, So.
And they're usually not taking into account all of the ground clutter and basically the fact that real cities are a lot of concrete and a lot of angular structures, slab-sided walls, etc., which are going to play havoc with your signal due to absorption and reflection and all sorts of other
urban canyons. Yes.
Yes, urban canyons.
I guess I'd expect that if they're going to do it on 900 and they're going to do it in Part 15 emission limits, that it would be fixed antennas at both ends of the circuit, that you could fairly easily put up a central tower to be the uplink and do something like I've seen in some of the community wireless cable systems. That's not the right term for those things, but they put the 20-foot TV mast on the roof and a little dish at the top of it that looks like a wind hazard. If you did something like that, I'm sure you could make it work reasonably effectively, but that segment of spectrum is only 26 megahertz wide, and So you're not going to get a significant amount of bandwidth through it if you've got more than one provider in the area trying to use the spectrum. Plus, there's an awful lot of other stuff like old microwaves and hams and government radars and so forth on that band that are primary users. And the hams get to put 1,500 watts out there if they feel like it and can justify it. So I think there's some hazards in trying to build your system depending on that.
Actually, one of the things that I would like to point out, because we really haven't come to ham radio too much, is you brought that up. If you're a ham, or if you have a amateur radio license, you can do 802.11 experiments, pursuant to Part 97. So there's certain rules on encryption and profanity and whatnot. But you can run significantly large amounts of power in 802.11 legally.
Like 1,500 watts.
Yeah, 802.11g, you can run 1,500 watts point to point if you want to, and fry turkeys with your ping packets. Yeah.
Well, to be honest,
the rule is
reach the 7 miles up the river point to point on 2.4 gigahertz on a lot less
but
than 1,500 watts. You could easily do it probably on about 400 or 500 milliamps.
Yeah. So
depending on that's depending on that's assuming a clear line of sight between the two antennae. If there are foliage and things like that in the way, you're going to have to up the power.
So 1.5 kilowatt, can I burn down intervening trees?
Eventually.
Yeah,
I was about to say, if it's right next to it, I'm not putting any bets on the tree.
And the squirrel population is probably going to go down too.
Yeah, it's a squirrel sterilizer, Mark II.
There would be some regulatory issues with that. You don't want to run your internet connection over ham radio because there are things in the regulations that prohibit encryption and profanity or obscenity. And what fun is the internet without obscenity?
Well, also...
Yeah, no FARC.
Try to plug into PayPal.
Yeah, I was going to say, if you're trying to conduct business over the internet, like perhaps you're going to use the wireless bridge up in Canada to run your consulting practice while you're there or whatever, that would be prohibited.
If you were running power as a ham, yes.
Yeah, if you were under Part 97, you cannot do commercial activities.
I hate to say this, Canada doesn't have Part 97. I don't know. I don't know what the relevant Canadian regulation part is. Unfortunately, I'm not familiar with
aren't the amateur rules fairly standard worldwide?
No.
No? Okay.
No, unfortunately, they're not. Canada and the United States have to, because we sit right next to each other and share so much border, there's a lot of coordination between the two, though, as to what can and can't be done.
Sorry in advance if this is an unfair question. What about an area where you can neither assume that people are technically gifted enough to build their own bow tie or Pringles can, and also probably too impoverished to buy very standard equipment? Are they just sunk, or is there any possible community solution for some, like very poor part of inner city Detroit or Cleveland, like that,
Well, yeah, to be honest, it's kind of difficult to say, but basically you're optimizing. It's kind of like people talk about in software engineering: cheap, good, fast, pick two. And if you're looking for cheap and good, you're basically looking at building it yourself. Now, a lot of the community projects, again, funding is always their issue, but a lot of them we're looking at, the easy thing to do is to start training people in those areas, like basically building up the level of technical knowledge so that you are teaching people, here's how you make an antenna, and either people can make their own antennas, that doesn't tend to work very well, or basically what does work well is you take some, say, high school students who might be taking something like Metal Shop, and you teach them how to start turning out on a maybe cottage industry basis some kind of cheap omnidirectional antenna or things like that you can. Now granted, the problem that you're getting into here from a legal perspective is under Part 15, the entire device is certified. So we're talking about the wireless radio, the antenna, and if there's an amplifier there, anything like that. So when municipal projects do this, they are technically violating federal law under Part 15 because the antennas that they make are probably not going to be certified, because that's what makes antennas expensive. They're all just little pieces of metal.
Well, actually, Part 15 says that if you're type certifying under a certain thing, or if you want it completely type certified as a sold, to sell it needs to be type certified. However, if you're doing it on your own under Part 15 as an experimenter, as long as you don't exceed a certain gain or a certain effective radiated power, you really aren't violating the law. This being said, it is the least enforced FCC reg, I think, in existence. I mean, seriously, when you can get cordless phones off of eBay from China that are on 900 megahertz, splatter the whole band, and you can talk for 3 miles, there's a problem, because those aren't legal. But so you can do that, and to kind of tie into what you're saying, it does fall into faster, better, faster, cheaper. Either you're going to buy it or you're going to make it. I got my amateur radio license at 13. I got somebody. My parents gave me a radio for Christmas. All I had was a little rubber duck antenna on top of it, and I was cutting lawns. So I also got a copy of the AWR handbook, which, by the way, if anybody's interested in playing around with radios, antennas, and general electronics, it's probably the best thing you can drop your money on, because it's going to cover all of those topics. And from there, basically learned how to solder up my own antennas, because I didn't have the cash to do anything as a kid to do that. And I do want to credit it for a lot of where I'm at in terms of getting started in consulting and the business and the work I do with computing and networking and whatnot. So as he's saying, if you get these programs started and get kids interested in the technology, because it's kind of going way off the physics topic, but it does provide a lot more avenues for them to figure this out. So it's either buy it or build it, but build it, in my opinion, might actually be the way to go, because you can start teaching people useful things that way.
And also, there's a number of aspects to a lot of these projects. One of the ones that I volunteer in Southwest Detroit is a good example. That part of the goal of the project is to elevate actually, let's put it this way, increase the number of people who are adept at different technologies, and because they can count these things as job training programs then, and that also opens up another avenue for potential funding, et cetera. So have I sufficiently answered your question?
Can I ask a very specific question in order to produce a desired answer?
Uh-oh.
We're in trouble now.
Let's say that I've got 2 locations, and they're not terribly far from each other, and all I need is near ISDN speed between them. And I only have a budget of $50. What do I do?
And you want near ISDN speed. Well,
he's already built this.
Yeah, for the record, he's already set this up, and it works pretty darn well, as I understand it. Though if you're not careful, we do have a few minutes left. We can still haul you up here. There's still a chair. Anybody, Dennis, you want to lead off on this one? You've been very quiet.
Go ahead. How many people have heard of Ricochet?
Oh, cool.
They were just in the news last week because they've now officially gone out of business finally.
There's lots of cheap radios on eBay.
For the 4th time.
So yeah, the Metrocom Ricochet network, which was originally a going concern in their second level rollout was in 2001?
About that, yeah, and in various areas before they went belly up shortly thereafter. They started around 2000 on the second gen stuff, really. The modems are sitting out there incredibly cheap. They are a pair of 900 megahertz modems, or you can go buy a pair of these like stupidly inexpensive, like $20 if you're, for everything.
Sometimes less than that.
Sometimes less than that.
If you're willing to buy a lot of them, like 10 or 12, you can get them for like $5 each.
Now, the useful thing about these things is even though the network's gone, you can dial another modem by doing the serial number and put a terminal server on the end, or the PPP dial-up server on the end. Very interference-free, very robust, for decently long range. If you're willing to hack them and add an antenna connector to them, you can bolt them to a 900 megahertz antenna and connect the link at near ISDN speeds, short haul.
And there's a wiki out there, which I think is ricochet.wikispaces.com, that you can go for a lot more technical information.
How far is the usable range?
Well, let's see. How far apart is the link? Quarter mile, half mile? 1.6 miles.
At least 1.6 miles.
Rubber duck to rubber duck, quarter to half a mile.
And that's the built-in antenna.
Not particularly optimal conditions. The modems can relatively simply be adjusted to have a more standard antenna jack. I think the common mod we've been doing is to put an end connector on them, take the internal high-rose attached rubber duck off, and we had to hunt around to find the right connectors, but somebody found them. You can't actually order them. and then you can hook up whatever 900 megahertz beam you want. The standard Ricochet modem is pocket-sized gadget.
They're about,
he's got one there.
as big as
Or the device he's actually holding up right now.
Yeah.
So 1 watt spread spectrum 900 megahertz radio.
And they're going for pennies on the dollar. And if you just need a dumb
warehouses
serial
full of them
modem,
somewhere.
yeah, or less than that. Or if you need 2 point-to-point serial links, they're pretty good. Because you can also use them as terminals. Or just
USB or
terminals.
serial connected, and Hayes AT command set. This is like the ultimate clever hackable toy for short links. Serial port extenders when you can't run cable for 200 feet. Links like this, if you're willing to do a little bit of antenna modification.
Yeah,
essentially, imagine a wireless networking device that was entirely built by hams and hackers, and that's what these things are.
Yeah.
They are designed when you take them apart. I mean, well, it's not like they scream hack me, but when you take them apart, you look at them, and if you have any kind of background in electronics or are willing to learn that stuff, you realize the way they've been built, you can go to Radio Shack or wherever else you want, DigiKey, and hack on these things to your heart's content.
Yeah, it's not a bad way to start learning some of this stuff either, because it's.
They were marketed by hams and hackers.
Yeah, and the reason they went out of business is they were marketed by hams and hackers, as Paul just said. I think we've got time for one more at this point.
Yeah, I think probably.
Okay. Do you guys have any ideas about the feasibility of building wireless community networks using mesh technology at this point, like open mesh? I know Meraki, they just went totally closed source, but what about open mesh? Do you guys have any experience with that?
I started out actually in community wireless networking with the Champaign-Urbana community wireless group, which I think is called CUWIN now. They may have changed their name since. I haven't really had much contact with them in the last several years since moving back to Michigan. But they are working on, I've always disliked the term mesh networking because mesh is a topology, and marketing has really mangled the concept of what we mean when we say mesh. But what you're really talking about is a massively dynamically routed network. And if you go to CUWIN's website, their software is probably still in beta, like all open source projects, but they're working on free open source routing software that will dynamically route over. I think the goal of their network is that you could scale it up to about 1,000 or 2,000 wireless nodes, by which I mean the wireless routers, not the customer premises user equipment. So basically, there's software out there that'll do what you're looking for.
It's feasible, but again, you have to keep in mind, when you're doing stuff like that, depending on where you're doing nodes, if you can somehow improve on what some of these other products are doing on large scales, you probably would have an edge and probably could win. Again, the problem is that you're dealing with unlicensed spectrum, and unless you're backhauling on 802.11a, you may find that if your nodes are spaced too close together, you'd have to play around with your node spacing quite a bit, because the mesh stuff will end up stepping on each other if you're not careful.
Well, I think that's pretty much all we have the time for now, but we're going to have a breakout session for the next couple hours up in the room where N5C, the NOTACON Special Events Amateur Radio Station is. So if you have any more questions and would like to ask us, we're going to be up there immediately following this talk.
Yeah, as well as we can cover more of the hands-on ham radio aspects as well, because there's a working ham station this year. Yay! Thanks to efforts of Bunsen and Dennis and others.
The coolest looking parts of it are kind of not user accessible right now, but we do have the control station that we can go set up in a few minutes and see how the bands are doing. Make some or show off some of the fun stuff you can do with ham radio and some of the more modern aspects of it instead of
it's not dead yet.
The old fart versions that you usually hear about.
I think that's about it. Yep. Thank you.
Thank you. Session, which we call a VA session. That's tomorrow at 9 a.m. Yes, I know the time is kind of poor, but if you're looking to get licensed as a ham, There's a website we can give you up in the N5C room that you can get started studying now, and you'll be ready to get your technician's class license, or if you're really wanting to go all the way, general or extra class, tomorrow at 9 in the morning.